Hey, good morning, guys. Welcome to episode 2 of Algebra. While I'm gone today, you're going to be looking at how to simplify expressions, whether we're multiplying two exponential expressions, and we're also going to be doing a recap on combining like terms, because multiplying two exponential expressions and combining like terms may look very similar, but they work in very different ways. This is going to be much shorter than yesterday. Yesterday I had to explain, we had to do a review of exponents, then talk about this idea of negative exponents. Today I'm mostly just going to be doing examples before you guys try some of your own, right? So let's get to it. So this is, if you want to follow along with the sections in our textbook, this is 7.2. And we're talking about multiplying powers. So we're going to be looking at another property of exponents. And when I say property of exponents, I'm talking about, we know that anything to the power of 0 is 1, and we looked at yesterday what we do with negative exponents. And so we wrote down those properties of exponents. In fact, how about I just write them right now so you guys can kind of do a little bit of so you guys know what I'm talking about. So, and you don't need to write this part down. I'm going to erase in just a moment, but just so you guys know what I mean when I say properties of exponents. One property is that anything to the power of 0 is just 1. Okay, so that's a property. What that means is that no matter what a happens to be, whether it's a number or a variable or even an entire mathematical expression, anything that's we raise to the power of 0 is equal to 1. And if you're right now thinking, wait, how does that work? We talked about it yesterday. So if you missed that, then when I get back, we can talk about it again. It's kind of one of those weird math things, but that's how it works. If you raise something to the power of 0, it's just 1. We also found that if I raise something to a negative exponent, then what happens is it moves across the fraction and becomes a positive exponent. So a to the power of negative n is 1 over a to the n. So if we had something like 4 to the power of negative 2, that would be 1 over 4 to the positive 2, or 1 over 16. So the answer is not negative, it's a reciprocal. If the negative exponent begins in the bottom, then we move it up to the top, and the exponent becomes positive. So when I say begins in the top, remember that we can take this and write it as a fraction with a denominator of 1, and so it moves over the fraction. If it starts in the bottom, then it moves up to the top of the fraction. So because I'm writing these rules in general, so in the blue I have a specific example, in black I have a general strategy that you can follow. That's what we call a property of exponents. So today we're going to discover another property of exponents. And we could actually figure this out on our own. So let's try it out. So let's consider how we might simplify 3 to the 4th power multiplied by 3 to the 2nd power. So an exponent is just repeated multiplication. So if I have 3 to the 4th power, that is literally 3 times 3 times 3 times 3. And so I expanded the power. I expanded it out. I wrote it as in its literal form. And then we have 3 times 3. So we've got our 4 3's here, and then we're multiplying that by 2 more 3's. That's what 3 to the 2nd power would mean. And so we add that all up, and we'd say, okay, well, this is the same as just 3 to the power of 6. 3 times 3 times 3 times 3 times 3, that's 6 3's being multiplied together. Well, if I just added 4 and 2 together, that would be 6. So now that we've expanded it out, we've learned, oh, well, next time I'll just add the exponents. So if I multiply two powers, so this is a power and that's a power, and when I multiply powers, I add their exponents together. Now, of course, I could just simply write this as 3 to the power of 6. So you don't have to leave it as 4 plus 2. We can make it 6, but I wanted to show you guys that I am just adding those exponents together. So now we have another property of exponents. If I have some power, say a to the power of m, and then I multiply that by a power with the same base. So this only works if it's the same base. So they're both 3's or they're both A's or they're both 5's. If I multiply powers with the same base, I add their exponents together. Just like that. So let's do some examples. So I'm just going to write them all out and we'll knock them out one by one. Hey, get off your phone. Did I make anybody jump? Okay. Let's simplify the following. So I'll write them all out and then we'll do them one at a time. All right. So first one's all numbers. It's 3 different powers being multiplied together. The powers that have the same base, if they have the same base, we can combine them together and add their exponents. So I've got 3 to the power of 2 times 2 to the power of 9. So I left the 3 to the second power alone because it didn't have the same base as the other 2 powers. But the powers that both had a base of 2, I was able to add their exponents. And actually, I wanted to write this out in a different way. I wanted to start with writing 4 plus 5, and then I'll write my final answer with 9. Now, by the way, this is a number. It's a really, really big number. It's what we would get if we did 3 times 3 times 2 times 2 times 2 times 2 times 2 times 2 times 2. 9 2's. So that's a really, really large number. So I'm not asking you guys to write out these really large values. Today, if I ask you to simplify an expression like this on today's assignment, I'd like you to leave it in its exponential form. Okay, I'm not asking us to type this all into a calculator. There will be a time where I might ask you to evaluate an expression, and evaluate typically means to try and get to just one value, one number, but I'm just trying to get you guys to practice simplifying using this property of exponents. This next example, we have some variables mixed in, but I don't see any exponents. So we have all kinds of invisible ones in math. We know that behind every variable there's an invisible 1. So if I just write x, I really mean 1 times x. We have another invisible 1. It's in the exponents place. So keep this rule in mind because this is really important. If an expression does not have an exponent, its exponent is 1. So this is 4 to the first power times x to the first power times 3 to the first power times x to the first power. When I just write it as x and x, we might be not sure, how do I combine those together? What am I adding? I'm here to tell you guys that if a variable does not have an exponent, its exponent is 1. So when we combine these together, we're going to be adding those exponents of 1. We've got 4 and 3, so we're going to write that as 4 times 3 times x. And let's add those exponents together. So we would write this as 12x to the second power. And you might be thinking, well, wait, you just told us not to multiply them. Let me say it this way. If it's something like 2 to the power of 9, that's going to take a lot of numbers to write. It would be easier just to write 2 to the 9th power. 2 to the 9th power is a number that takes 15 digits to write. So it's simpler to write 2 to the power of 9. If I have 4 to the power of 1 and 3 to the power of 1, we can just write that as 12. So I know that that's a little confusing because you really have to think about what's in front of you. But let me just kind of restate. If it's as easy as just multiplying 4 by 3, then I'd like you to write 12. If it's something that's going to require you take out a calculator and multiply and multiply and multiply until you get to this enormous number, then I'd like you to just leave it as 2 to the power of 9. On today's assignment, part of it's going to be a matching exercise where you'll be provided with the answers, and so you guys will start to see how I'd like you to write your answers, because you'll be matching your questions to the correct answers, so you'll see what the answer should look like as you go through today's assignment. So with this last problem, we've got numbers and we have variables. So here's what I'd like you guys to do. I'd like you to start by multiplying the big numbers together. 2 times 5, that's 10. Then I'd like you to add the exponents above each variable. So we have x to the second power, x, and there's not an exponent there, so that's x to the first power. So we would make that x to the third power. So I just simply multiplied to the big numbers 2 and 5 to make 10, and I added the exponents above the x's to make x to the third power. And then we have y to the 9th power when I add 5 and 4 together. Okay, easy as that. Multiply the big numbers, add the little numbers together if they're above the same variable. So I notice I didn't write this as xy to the 12th power. I can only add the exponents if they have the same base, if the big number is the same for both expressions. So you guys are almost ready to get going today, but I want to make sure that we do not get this confused with combining like terms. Because when I've taught this lesson in the past, it often conflicts with our understanding of combining like terms. So let's talk about the difference between these two ideas. So I'm going to title this Combining Like Terms versus multiplying powers. So let me remind you, we can only add or subtract like terms. If you want to add or subtract two terms, they have to be like terms. They both have to have the same variable and the same exponent. So let's do an example. Let's say I had 3x squared plus 2y minus 5x plus 4y plus x. So first, let's identify the like terms. That means we're looking for terms that have the same variable and the same exponent. So immediately I see we've got a positive 2y, a positive 4y, so those can be combined together. We have a negative 5x and a positive 1x. That's not like the 3x to the second power. So this guy has an x, but it has an exponent of 2. That means it's not like the other terms. So when I go to simplify this expression, I have to leave it as 3x squared, but I can combine the 4y and the 2y to make 6y, and I can combine the negative 5 and the positive 1 to make negative 4x. And that is my simplified answer. I can't take it any further than that. I cannot simplify this further. It doesn't look very pretty, but I can only add or subtract if they are like terms. So none of these are like terms. However, we can multiply on like terms. In other words, when you're multiplying terms together, you should be able to write it as one giant expression. So let's say we had 3x squared times 2y times negative 5x times 4y times x. Let's say I multiplied all that together. So this might look like subtraction, but I've got parentheses, so that's multiplied by negative 5. I can combine all this together. They don't have to be like terms. So how I'm going to do that is I'm going to multiply the big numbers. 3 times 2 is 6. 6 times negative 5 is negative 30. And then negative 30 times 4 is negative 120. So if you're wondering, wait, where do you get that? That negative 120 is from me multiplying 3 by 2 by negative 5 by 4 by 1. Now I'm going to add the exponents above the above each variable. So if I'm adding the exponents above x, that's 2 plus 1 plus 1. So don't forget the variables that don't have an exponent, they have an exponent of 1. 2 plus 1 plus 1 is 4. And then the y's also have a 1 above them. So when I add the exponents above y, I get y to the second power. So when we're combining like terms, we might only be able to get it down to 3 terms, depending on how many of them are like terms and how many of them are not like terms. When I am multiplying terms together, I can actually get it down to 1 number and 1 of each variable. Today's assignment, you're going to be looking at examples of both combining like terms and multiplying powers. And on each side of the paper, there's instructions to follow if you get stuck, and you start with some matching exercises. So the solutions are provided. You just have to figure out which of the answers which of the problems on the left match each of the answers on the right-hand side. You can draw a line to connect them. You could write the letter of each answer. I don't really care. Just try to make it clear. So don't do the loop-de-loop thing that drives my TAs crazy. And then just followed up by some problems you have to try on your own. Okay? So good luck, guys.